Boys and girls, ladies and gentlemen, Jesse Warden here. Today we're going to talk about embedding effects into the type system to remove the need for using mocks in unit tests.
Jesse Warden.
What's wrong with mocks? Well, number one, lots of setup, lots of code just to test one line of function or one class method. Number two, soon as you test implementation, how your code works, you defeat the whole point of abstraction. So why are you abstracting things? Number three, because your tests know about the implementation, if you just change one little modification to make it faster or maybe more readable, you can break the test, even though the code technically still works. Now, suddenly all your tests are not fun to work with because you just tweak the code even a little bit and the whole thing breaks. You can remove all that, and there's a variety of different ways. Now, I've talked a lot on this channel about using stubs instead of mocks because stubs are pure functions. They're deterministic. You can guarantee happy path, unhappy path, and it automatically gives you for free the ability for tests to run in isolation. You can literally put those stubs inside the test. You don't have to put them before or after each, or you could just import them. There's no state. Mocks don't have that. State you have to remember. They have to be in the test flow, the whole setup and tear down nonsense. And because it's mutation, it risks the test not working in isolation and your code not working in isolation, assuming your code isn't doing mutation. Mutation is bad in your code just as it's bad in your test. Now, yes, I know mutation is for fast code and things like that. There's a reason Rust has a borrow checker. It's dangerous, right? Rust default is immutable. A lot of the stuff that we're doing in Node.js, we're not going to use mutation. It's optimized for immutability and shallow copy with object destruction. We should default to immutability as well too. And that's why I've always talked about stubs. What we're trying to do is test behavior. What does the code do? We don't care how it does it. Did it work or not? Let us know. One thing that can do that is a type system. This is a great way to get rid of mocks totally. We have a greet function here, and what we're trying to do is test it. So you call greet with some kind of name, in this case, Jesse, and it assembles it into a greeting. Hello, Jesse, and then logs it, and then returns the greeting. So testing this is pretty straightforward because we get the greeting back and we know what we put in, what we're expecting kind of out. Let's test this and see what I'm talking about. So we're going to go to get some kind of greeting back from this greet function. And we're going to pass in array, that's me. And what we're expecting from this greeting is to be hello, array. Cool, so far so good. So we've got a failing test and it says greet isn't there. And let's make sure we can get it to fail, not just from importing the function. Import greet from mock example. Cool. So now it's saying that our greeting isn't quite lined up, which is perfect. So we can red, green. Now we can refactor. Okay. So we're not going to refactor code. What we are going to do is detect what are we not testing here. So in a test last scenario, let's say or test after, you've got code and you're having to add unit tests to it. The first thing you're going to notice about this greet function here is that it's got a console log. And the reason that's important, especially for server-side developers, but it's becoming increasingly important for front-end developers, is that you have logs about what happens in your application. And when something breaks in production, you're going to want to see that, whether it's CloudWatch, New Relic, Splunk, whatever your observability system is. You're going to add these logs to kind of tell a story with some kind of correlation ID that you can see the whole journey. How do we test that it actually logged? Because this function isn't doing one thing. It's not just returning a greeting. It's logging it out. The mockest approach would be to say, should call console.log. And what they'll do is they'll create what's called a test double. And there's a variety of test doubles. One of them that JavaScript and TypeScript use a lot is called spies. And the reason they like spies is because you don't even have to use dependency injection. You can literally mutate the original class, module, or object, spy on a particular method or function, and see how it's used and make expectations against those things. So we're going to create a console spy here. And we're going to say spy on. Import V and say spy on. We're going to spy on the console, and we're specifically looking at the log function, or in this case, log method of that console class. Then we're going to call log greet. We're just going to ignore the return value. And then we're going to expect that the console spy expect it not to have been called. Okay, let's scroll up. The number of calls were 1, and it was called with this data. So we've got our red test failing, so we know it fails for the correct reason. We're going to turn it to expectation of it should be called. Cool. So now we have two tests for one particular method. We're testing kind of two behavior things. First, did you return the greeting in the way we're expecting? Hello, the name, and an exclamation point to be exuberant. Cool. Fantastic. Second test, did you actually call the console log in the way I expect? Well, greet was supposed to be a function, and this could be a class method too, to abstract away how greetings work. Not anymore. You know how it works. You know that internally somewhere it's using a console and it's calling log and you're expecting it to work. This is the anti-pattern. This is what we're trying to get rid of, because now if you change anything about this function, this is pretty easy to move around. You can refactor a little bit. There's not much you can really refactor too much, but when you get lots of these kind of mocks and dependencies that are not being injected and you want to test them, it becomes a mess to set up all these spies, a mess to reset them and remember to set them. A lot of your tests become flaky, either because of the mutation reason, or if they're not flaky, they become very verbose because there's a lot to set up and read, or they're hard to change, even though you didn't change how the code actually worked. It's how can we remedy that? Well, we're going to offload this to the type system and return a value. Just using a non-type system like JavaScript or Ruby or Lua or some other dynamic language, you can use the return value as a step one. So here we have our effect example. So we're going to copy pasta, coding for the win. If you come from a functional programming background, and again, this isn't really fair to say functional, it's more from a really good type system background, but it kind of like is a gateway to functional programming because they type what they return. Everything returns. This is why a lot of those things don't even have the return keyword. You just return values like this in Rescript and OCaml and a lot of other languages, because why wouldn't you? It's algebra. And so that idea is that you're always going to get some kind of type back. So I'm sure you've seen code like this, which just doesn't return anything. It's almost always void, right? But in this case, we were explicit. No, greet returns a string. And that's good. It's a great start because it does do something. It creates a greeting and gives you back, but it does other things. So let's capture those other things in the type system. In functional programming, console log and its ilk for logging standard out returns values. Seems weird, but it does. So let's go create a log function that does something very similar. It takes an unknown value, but then it returns an unknown value back. So it's kind of like an identity function. What you give it, it gives you back. So we're going to say, I'm going to give you a value. I want you to return it back. Okay, so far, so good. You get how we pass in a value and it immediately returns that value. Okay, so pretty simple, easy to read, easy to understand what it's doing. It's almost too simple. We're going to wrap the console. So now instead of console log always returning undefined, it's now going to be more of a pure function that it always returns undefined. That's certainly useful. It's going to log what it logged. And this has consequences when you start using things like Splunk and New Relic, and you create these object chain log messages that you want to query against. We're going to leverage that here by starting with just unknown. We can refactor this later, but look what we've done here. All we've done is have console log return what it logged. That's really all it does. So now the way we're going to enforce that you called this is we need to get a log message. What's a log message? Well, you name your variables. Let's name our types. So we're going to call a type log message. I don't know. It's unknown. So all we did was an alias that's just a name. We're not going to really gain type safety, but we are going to get is read safety. We can read this code and see it's returning a log message. So passing an unknown, it's a log message. Greet does two things. So it creates a greeting, which is a string, but it also returns a log message. So let's kind of be a little bit more explicit of that too. So we're going to say greeting is a string. And so now it returns two things, a greeting and a log message. And so it's not just a string anymore, although it technically is a string, and a log message, which is technically unknown. But now we return two things because the function does two things and the type system requires you to do two things. So let's change this to log greeting, log message. And now we're required to return both. So we're going to return a greeting and a log message. We've got a log message. We've got a log function. That log function just wraps console and says, look, I'm going to return what you sent me. So at least you have some kind of valuable return value other than undefined, because that's all the console log and info and all those guys send, okay? We're then going to capture that value and embed it in the type system. So we're now returning a tuple or an array with two items that can be different types. A greeting is the first and a log message. Let's go write a unit test for this and see how we can get rid of mocks. Let's run our tests. And let's make it fail, baby. We're going to do something similar that we did before. But remember, it's an array, and the first item is the greeting. So we have to do greeting inside an array. And we'll say greet array, that's me, expect greeting to be hello array. Good to see ya. Rock on. And then we'll import it. And let's change it up just to make sure it fails. Import greet from to effect example. And it is mad because it doesn't match perfectly. Now it's green. Fantastic. How do we test the console? Well, you remember, without a mock, we got a log message as the second parameter. And currently, that log message per the type system is pretty much the same value. So we know that it did the right greeting because we can see it and it is what we expect. That's fantastic. But we can also detect that it called console log because it returned the message that called console log. And we've used this function to test the private function. Private class method in this case is a function that's not exposed. And now we have confidence. So we were testing return values and we embedded it in the type system. Okay, so that's how you don't use mocks from a dynamic perspective. How does types really help with this? Well, beyond spelling and other type stuff, let's take a look at greet. What happens if I do it the old school way and just, I'm an imperative OOP coder, I don't return values? Oh, wait, it won't compile. The only way to get a log message is to call log. So you have to call log, else you can't get in a log message. If you don't have a log message, you can't return it as the second parameter of the array. If you can't do that, you ain't compiling your code, bro. And we ain't even running unit tests because your code isn't JavaScript yet. Isn't that awesome? That is how you get rid of mocks, embedding your effects or anything with IO into the type system, requiring it, and then offloading it to TypeScript to say, I have to call this because I have to get the type, because I have to return it so my program compiles so I can run my unit tests. You got any other questions? My name is Jesse Warden, here to help. I'm on Twitter, I'm on LinkedIn, cringe, and YouTube. Drop a message in the comments. I'll help you out. Have a good one.